That's okay. That's okay. You had minor errors there. Okay. Here we are. I'm going to try to review entire chapter 6 with the handout that I gave you some time ago. And then we have 6 sections. This is a short unit. 6 sections in chapter 11. 11, 1, 2, 3, 4, 5, and 6. Okay? So a lot of these will be covered in that handout that I gave you and that I'm going to go over today. I am thinking that our third test will start on November the 9th. So it's about 2 weeks from now. So I'm hoping. We'll see. Now, I would like to make up the Thursday of Thanksgiving. Is there any way you could come on a Tuesday also from 4:30? Can you? Heather, can you? Yes. So I would like next Tuesday, if we can meet here at 4:30. And Thursday, of course. Just I need to give you an extra class because of the Thanksgiving that we were not going to meet. Okay. So I will email everyone, and just a reminder for next Tuesday at 4:30 in the same room. Okay. So this is what I'm trying to do, all these sections. So here, once again, here's where we are. We are getting ready for test 3 now. So these are the chapters. So this says only 6.6, but I'm going to review everything with you. Entire chapter 6, which was completely done in 011. But it doesn't appear that we remember those topics. So then we're going to continue with chapter 11, 6 sections. Okay? Good. This is the handout that I plan on going over today. It's a long handout. However, it has, 5, 6, 7 pages. However, it's not going to be, it's going to take us about 2 hours to finish this. So factoring strategy is the entire chapter 6, and the follow strategy is divided in 3 major groups. I do not present this chapter even when I teach 011. I do not present it in the order the book is presenting it. I don't think it's the correct order. I present it into divided into 3 different parts: binomials, trinomials, and polynomials, because that's what we are looking at. And if you just browse to the last page for a second, you will see a little chart that I created, and it will take us through all the steps that I'm going to mention in a minute, but you will see at the very end, it's separated, completely separated into 3 different parts. Binomials are here, trinomials are here, and polynomials are here. So that's the reason why I presented them into 3 groups. Good. So now, the first thing that I have to do is, today is this 26, I think. Okay. So whenever I am asked to factor, or I have to factor, the first thought, the first question that comes to my mind is, what is it? And the answer has to be either a binomial, or a trinomial, or a polynomial. That's my first question to myself. My second question is descending order. That's my second question. If the polynomial is not, and you see that right here. So questions and steps to rigorously follow so please rigorously follow these presented in this order of the steps presented here. Okay? And also you can look for a summary, as I said, on the last page. So first of all, my first question is, what is it? And the second question is, check whether the polynomial you need to factor is presented in descending order of the powers of the variable. If not, I should put a comma here, sorry. You must rearrange it in descending order of the powers of the variable. Okay. Number 3, greatest common factor. Third thing that I have to look at is check whether, that's part B here, check whether there is a greatest common factor in all terms. If there is, then you must factor it out and use parentheses to separate it from the rest of the polynomial. We'll have examples in a minute. Step number 4. Leading coefficient negative. These two can be put together in the same step if you want to. Check if the polynomial's leading coefficient is negative. If there is, or if it is, then you must factor it out together with the greatest common factor. If you found one in step C above. Step C and D can be performed at the same time. Okay, the next step from now on is different. If it is a binomial, I'll do something. If it's a trinomial, I'll do something else. If it's a polynomial, I'll do something else. Okay? So now I'm going to start with binomials and then come back to this. So if it is a binomial, then I have 4 special products. Here they are, 4. You also see them on the next page, at the top. So if you turn the page to page 2, at the top, we see them. A squared minus b squared, a squared plus b squared, a cubed minus b cubed, which we have never seen before in this class yet, and a cubed plus b cubed. So these are the ones that I'm going to list right now. So a squared minus b squared, a squared plus b squared, a cubed minus b cubed, and a cubed plus b cubed. Now let's talk about each and every one of them. The first one is on our contract from the first day of classes. So a squared minus b squared. Do you remember where this comes from? What do we have on this side? What do I multiply to get a squared minus b squared? And I'll remind you where we use this. We use this in rationalizing the denominator, and we also used it in dividing complex numbers. So what did we use in rationalizing, and what did we also use in dividing complex numbers? That's the formula I need. And it was on our contract.
The trinomial.
No,
No?
not yet. We are not in trinomials. This is a binomial. Just look it up and tell me what it is. So you know where it is. I'm not trying to torture you. I just want you to remember where it is and where it's coming from. Which special product did we use when we rationalized the denominator? Let's say I have the square root of x plus the square root of y. What do I need? If the denominator is the square root of x plus the square root of y, what do I rationalize it? Using what?
The
Square root of...
square root of x. You said yours was plus?
Yes,
So then the square root of
exactly.
x
That's
minus-
exactly what I have here. Because that's how I use it. Squaring the first minus squaring the second. So then what do you think I have to write? Exactly what you just said. No. A plus b
That's what I was thinking.
times.
A plus B or A minus B.
Exactly. So that is going back or backwards. Remember, initially we wrote this to come up with that. Now in factoring, I have to change a sum or a difference of terms into a product. I'm factoring it. So this is called the difference of squares. and it has at least two immediate applicabilities from the previous chapter. What were they again? When did we use this formula? In chapter 10 to rationalize denominators and also to divide complex numbers, right? We had to multiply. If the denominator was 3 minus I had to multiply by 3 plus I and 3 plus I. So this is the conjugate, right?
Yes.
Right. So at least two immediate applications from the previous chapter right away. This is it. Difference of squares. So when I see this, I have to be able to come up with this. When I see this, I'll say, oh, I know. It factors into these two. Okay? This one is the sum of squares. It's not factorable. To be exact, I should write not factorable, and I'll put in parentheses using integers. It could be factorable, but we're not really interested most of the time. We're not really interested to factor if it's not integers. So, for example, I can factor it using complex numbers, but that's not what we want to do. Your book, in this situation, uses a word prime. I don't specifically care for it for a polynomial or binomial in this case, but they just say it's prime or not factorable. I'm fine. I prefer not factorable. The sum of squares is not factorable. But you can write prime. I accept it. I think it's better to write not factorable. Now, how do you think we call these two? We haven't seen them before, so we need to work on those a little bit. So what do you think this will be called? And how do you think this will be called? Obviously, it's a difference of what? Yes, perfect cubes. What do you think we're going to call the last one? Of course. Sum of perfect cubes, of course. Thank you. Very good. Okay. Are they factorable? Yes. Both of them. So let's come back here for a moment. The difference of squares is factorable. The sum of squares is not. But when it comes to the sum and difference of cubes, they are both factorable. Okay? So let me give you the formula. When we factor the difference of cubes or the sum of cubes, we will have to come up with a binomial and a trinomial. These will appear to be the most difficult to factor. They're not. Once you understand the pattern, they're not. Okay? So if I factor the difference, the binomial must have the difference, and the trinomial will have the sum. If I factor the sum, what do you think will happen? Just give me your wild guess. If I factor the sum, what will the binomial have? Exactly. Nothing changes on the last one. The last term is always positive no matter what. But the change will be in the second term here. So let's construct this together. What do you think I can cube to get a cubed? That should be a silly question. What do I cube to get a cubed? Of course. What do you think I cube to get b cubed? Good. So now the trinomial is not difficult. Once I have these two numbers, here's what I do. I square the first term and I put it here. I square the last term and I put it here. And the middle one, if you remember from a different formula, has 2 times AB. This one doesn't have the 2. So it's just AB. So now we understood the formula, and we can multiply them to just check once. So which one would you like to multiply? Would you like to multiply a minus b times a squared plus ab plus b squared, or the other one, a plus b, a squared minus ab plus b squared? I want to multiply once, one or the two, and check that it's indeed the left-hand side. So the formula will be clear to us, but when we apply it in problems, it's not going to be that easy. I have to be careful. But once I get the pattern in my head, a plus b or a minus b, and a squared plus or minus ab plus b squared, once I get the pattern, it should not be that difficult. So which one would you like to check? The first one? Yes? Okay, so let's check the first one with a minus b, a squared plus ab plus b squared. So this is a binomial and this is a trinomial, and I need to multiply them. I will distribute a to these three terms, and then I will distribute negative b to these three terms. The result should be what? How much? When I'm done, what should I get as the answer? A cubed minus, right? So I'm multiplying this by this, and if I don't get this, something is wrong. Okay, so a times a squared, a times ab, excellent, plus a times b squared, excellent. Now negative b times a squared is minus a squared b. Negative b times ab is minus ab squared. And negative b times b squared is minus b cubed, indeed. How many terms should be left? 2. So 4 of those have to cancel each other out. So let's see. I see an a squared b with a negative a squared b. I see an ab squared with a negative ab squared. So is the answer correct as what we expected? Is it a cubed minus b cubed? True? Okay. So now let's apply these formulas in problems. So let's come back to the first page of the handout. Factor of the greatest common factor if it exists. The greatest common factor is, please tell me in words, what is the greatest common factor? So I can apply the greatest common factor here. A factor of the greatest common factor. So what will you say in words is the greatest common factor? Is a factor that goes into all terms. Is common, if you want, to all terms. Or I can divide all terms by that factor, and I get an integer as a result. So the greatest common factor is a number or a monomial. It can have x or y in it. It can have variables that I can divide each term by. Or each term is divisible by it. Whatever you want to write. So now I have, as the first example here, negative 2xy to the 5th plus 3x cubed y to the 6th. By mistake, I wrote x to the 5th. That's not in the problem. Now, can anyone remind us what is the degree of this piece? Just the first monomial. What is the degree? And how do we determine the degree of a monomial? In order to find the degree of a monomial, I have to add the exponents of all variables present in that monomial. So what will be the degree of this monomial then? Perfect. What will be the degree of this monomial? Yes. What is the degree? So degree. What is the degree of the entire polynomial? I cannot add them. I can only choose the largest. 9. So therefore, I will rearrange this polynomial as 3x cubed y to the 6th minus 2x y to the 5th. Because I have to arrange it in descending order. It is always wise to arrange it in descending order. Good. So now I see it has common factors. Can anyone give us what is common to both? Yes, x is common. At which power? The smallest of the two. Yes, perfect. Now y is common at the power smallest of the two. Indeed. How many terms will you write in parentheses? Exactly 2. You started with 2, you have to have 2. Because you want to recover them if need be. When you multiply this by something, you'll tell me I will get this. And when you multiply this by something, you'll tell me again, I'll get this. So what is left from the first monomial? Excellent. Minus. What is left from the second monomial? That's it.